Hi, we are group number 11, and our project is about autonomous classification of 3D geometric shapes using a UR10E. We are Roberto Estrada, Domenica Santamaria, and Geoffrey Ortiz. Next, please. So, the objective of this project is to develop a simulation-based autonomous system for identifying, classifying, and sorting 3D geometric objects using a UR10E manipulator. The platforms we use are ROS2, Gazebo Classic, Movie2, OpenCV, and SolidWorks. Next, please. Well, our methodology was divided into main stage to develop and validate the autonomous sorting system. First, we created the virtual work cell in Gazebo Classic using ROS2 to connect the different components. Then, we modeled and integrated the UR10E robots, the conveyor belts, and the custom end effector. Next, we developed the robot cinematic model using the 10-bit Hattenberg conversion and used Movie2 for trajectory planning and collision avoidance. For perception, we implement a multi-view RGB camera capturing 4 views of each object and process the images with OpenCV to identify geometric characteristics. We also use QR codes to dynamically determine the destination of each object. After classification, the robot performed the pick-and-place sequence, moving each object to its corresponding destination. Finally, we integrated all the models and validated the complete system by evaluating the robot's manipulation, object classification, and overall autonomous sorting process. Next, please. So the simulation work cell, we can see here the environment where we work. We took this robot from GitHub and it's a 6 degree of freedom. Also, we took from GitHub the conversion belts and we modified as we wanted. You also can see here the inspection area, destination boxes, multi-view cameras, and the geometric objects.
So for this part, at the start of each round, the robot's gonna scan the QR codes to match each boxes and know what is the shape it needs to be located. For the next part, it's gonna be the pick and place. So the robot gonna be align itself in the input conveyor and then gonna grab the object without knowing its shapes. For the next step, the robot's gonna rotate the object to capture its shapes using OpenCV. And finally, you're gonna do the pick and place. You're gonna put in the destination box to the correct location.
In this slide, we consider RB's planning scene. They are computing and executing the trajectory with active collision objects for safe motion planning, all the way through the release moment. The next slide, we see the analysis of shaping. The classifier takes the raw camera feed, applies a binary mask, and they analyze counter properties like singularity, aspect ratio, and convective effects. In the next slide, we can see the table that summarizes the logic. A sphere has a high circularity in all views, a cube has a 4 to 6 vertices, and a spring shows convexity effects, and a cylinder is circular from the top but rectangular from the side. And the next slide, we can see the result. We can see the video. So the full autonomous cycle running end-to-end, QR scan, pick, classify, and place, all organized through ROS2 and Movie2. Now we can see the video.
Overall, the system successfully achieved autonomous sorting, but we have recommendation that we like to come with you. Improve physical modeling of destination boxes, optimize gazebo spawn delete synchronization, and continue improving collision avoidance mechanism. And that's it. Thank you.